Hi studying engineers, welcome back to the another video. In this video we will discuss about external pressure. In last video we have discussed about internal pressure. We have divided the pressure into two terms. One is internal and another one is external. In this video we will discuss about external pressure. Last video we have discussed about internal pressure. If you have not watched that video, just check the video. And now we will see about external pressure. What is external pressure? How the vessel experience external pressure? From this image you can able to see that the vessel has completely collapsed. It is not burst or it is not blast. It is imploded. It's kind of a fusion. This is happened because of external pressure. The vessel doesn't explode during the external pressure, it implodes. And why it is an important one? It doesn't shows any sign before it collapses. It will be a catastrophic one. It will happen in a seconds. It will happen completely in seconds and there is no visual sign or anything before collapse. So it is very important to calculate the external pressure. In simple terms, you discuss about internal and external pressure. Means the internal pressure we will tell it as kind of a tensile stress, and the external one as a compressive stress. The internal pressure pushes outward. In this image there is internal pressure. You can experience that it will push outwards. Pressure will act on the inside surface of the vessel, but in external pressure the pressure will act outwards. The vessel external wall, the outer wall, will experience the external pressure. What is external pressure? How the external pressure happens? If you consider internal pressure, you already knows there will be some process. Due to that process internal pressure will be there. But how the external pressure occurs? The external pressure is often caused by the weight of the atmosphere. You have already know that we have atmosphere, the earth has atmosphere. Due to the atmosphere there is some weight, there is some pressure. Due to that pressure we are experiencing, and the vessel is also experiencing the external pressure. Is it the only thing the vessel experience external pressure? Means no. The external pressure often occurs during emptying the vessel. If the vessel is instantly get cooled or vessel is getting pumped out. And another one thing, if the vessel has any jacketed. If the vessel is jacketed and it is multi-layered vessel, then there will be some external pressure. The external pressure is broadly identified as vacuum. If you are considering vacuum, there are two kinds of vacuum is there. In the specification you can able to see sometimes it will be full vacuum and sometimes it will be partial vacuum. What is full vacuum? If the vessel internal pressure drops to 0, normally the internal pressure will be 1, that is atmospheric pressure. If the internal pressure drops to 0, that will be full vacuum. There will be no pressure at all inside the vessel. There will be no atmospheric pressure too. Then we will call it as full vacuum. The atmospheric pressure, you know, it is 1 bar. If you convert it to psi, it is 14.7. This 14.7 psi is continuously acting on each and every square inches of the outside of the vessel. So what will happen? The vessel will collapse. Full vacuum is really worst case. It doesn't happen because we can't able to pull each and every atmospheric pressure from a particular vessel or anything. We can able to do that, but in pressure vessel it is not a common thing. But partial vacuum. Partial vacuum is completely normal. A vessel can experience the partial pressure. The partial vacuum is nothing but there will be some pressure, there will be some atmospheric pressure, but it is not equal to the atmospheric pressure. There will be some minus pressure, it will be negative, but it is not equal to the atmospheric pressure. For example, the vessel is operating at 5 psi inside of the vessel, then there will be some issues because the external pressure will act. If the vessel is operating at 5 psi, it creates the external pressure, it creates the external pressure crushing the vessel. But what we will commonly do is, if a vessel is experiencing partial vacuum, we will consider the vessel as a full vacuum and we will design for the full vacuum only, because specification they doesn't give exact number of the partial vacuum. They in specification they will directly provide it as a PV. PV means partial vacuum, and the exact values are not given. So we will consider full vacuum and we will design as per the full vacuum for the particular vessel. Now we will need to know the difference between buckling and bursting. How the bursting will happen and when the buckling will happen. Bursting is normally happen during the internal pressure. If the vessel is experiencing more internal pressure which is not designed for that particular internal pressure, then the vessel will burst. If a vessel is experiencing external pressure which is not designed for the external pressure, the vessel will buckle. In this picture you can able to see that the difference between bursting and buckling. If you go to any site and you have the opportunity to saw the vessel which is failed, you can able to easily identify how it is failed. If the vessel is ruptured, it must be due to internal pressure. If the vessel is buckled, then it will be due to external pressure. Why the external pressure governs the design? Normally internal pressure is the main factor we will consider during the pressure vessel design, but here external pressure is also act a major role in pressure vessel design. You can consider a soda bottle. Soda bottle means you can consider a coke can, the aluminum coke can, or any other Sprite or any other can. You can able to see that if you blow inside the coke can, you can't able to burst the can, but at the same time if you compress the can, if you press the can will easily collapse. That is the best example for external pressure. Why we need to concentrate more on external pressure means the external pressure suddenly collapse. It doesn't give any indications, it doesn't give any visual failure or anything. We can't able to predict it is going to fail, it will suddenly collapse. So we have to provide special importance to the external pressure. And in ASME also special methods are taken care for the external pressure comparing to the internal pressure, that we will discuss in further slides. And what is the common mistake we will do during the external pressure calculations? Ignoring the vacuum case completely. Actually what we will do is we will see the numbers. The numbers is normally given for internal pressure. We will see the numbers and we will ignore the letters which is come behind the number, like FB, PV, those kind of letters we will ignore. If there is FB is given, it must be calculated for external pressure. If there is PV is given, we have to consider the external pressure. Next thing, we will assume always the internal pressure govern the vessel. Sometimes yes, it is true, if the vessel is too long, then the external pressure will govern more than the internal pressure. So if the vessel is long and the vessel is thin, we have to calculate the external pressure. Sometimes this to happen in specification, these details will missed out, but as a design engineer you have to know that if the vessel is connected with a pump which is coming in the drain or in the suction or in the discharge, then you have to consider as a partial vacuum and you have to design the vessel for the external conditions also. Sometimes it will be missed out in the specifications. Sometimes client or EPC company doesn't knows about that. As a mechanical engineer, as a static equipment engineer, that is our duty, we have to do that. External pressure in ASME. How the ASME addresses the external pressure? The ASME has provided major importance for the external pressure. That's why they have provided a separated class for the external pressure. You can see in ASME Section 8 Division 1 UG 28. In future videos we can see about this UG 28 too. And ASME has not stopped there. ASME is providing a factor A and factor B charts which is depend on the geometry and the material charts, which we can able to see in section 2 part D. The main focus of designing the external pressure is length. What is the unsupported design length of the particular vessel? That will be the main factor of the external pressure calculation. And also the ASME providing what is the maximum unsupported length. We can able to use the calculations, and we can also reduce the unsupported length of the vessel using stiffness. Those calculations also given in ASME, and calculating the stiffener moment of inertia is also given in ASME. So ASME is taking extra care for the external pressure. Okay, we have came to the end of the video. Next video we will discuss about the design temperature. Design temperature is one of the important thing next to design pressure. Like design pressure, it is not much confusing. Design pressure, you can see that there are number of list of design pressures and it is splitted into two, internal, external. Those kind of dramas are not there in the design temperature. It's simple. We can see the design temperature next video. Okay, bye bye.